good students and fellow networkers. Welcome to another episode of Networking with Sir Gadwin. Today we are going to answer the packet tracer lab activity that configures EIGRP protocol and default static routing. So we will start. Let me share my screen first so that you may know what I am doing. Okay, here. So this is the packet tracer that we used a while ago with my students, answering the problem solving that all of this network here belongs to an EIGRP protocol. We are going to answer it using the computed CIDR addressing here and apply it to each of the network. So let's start. We are going to configure first the main router. We are going to apply the network address set here per computed in our CIDR computation. So enable config T, then we'll go to int G01 and IP add 130.15.192.1 255.255.255 dot. Since we computed this one with a subnet mask of 128, therefore there no shot. Then in G0/0/0. So this IP address here from at the top here was given by the ISP, and we are going to configure it in both router ISP and in our border router here in our organization. So that would be IP add 159.11.30.1 to 130 255.255.255.252 since it is slashed with 30. Enter no shot. Here in SE0/0/0/0, then we are going to give an IP address of 130.15.194.1 255.255.255.0, 128, enter, no shot. So this router here will be configured also. No, enable config in FA0/1 and IP add 130.15.192.2 255.255.255.128. Both of the routers are now turned on. We're going to configure also the interface FA0/1/0, then IP add 130.15.193.1 as the gateway, 255.255.255.128. Turn no shot. So basically, all of this computer here can ping its gateway. Let's try. Ping this computer to that computer, it's successful. So we are going to configure the F00 here. So int FA0/0 IP add 130.15.192.129 255.255.255.128 and turn no shot. Then we are going to configure also this router here with the G00. No, so enable config T in G00 LAN. Then we're going to IP that one as 130.15.192.130 255.255.255.128. Turn no shot. We are also going to configure the LAN. That's one. So in G0/ this one is G01. Then we're going to configure it with this IP address 130.15.192.130 255.255.255.128. There. Then we are going to configure the interface G0/1, then with IP add of 130.15.192.130 255.255.255.128. Enter. Then go to int G0/0 for the local area network. Then we're going to IP this one with 130.15.193.129. Enter. We lock 255.255.255.128. Enter. No shot. So basically, this PC here can ping this PC here. Let's try to troubleshoot this one. Why is it wala siya nag-green? So do show run. So the int G01 is still shut down. So we are going to go there and turn it on. So in G0/1, no shot. Turn on already. So this side of the router here, the main router is already configured. So let's go to the right side. Here, we're going to configure the IP address of this interface. So no, enable config T in SE0/0/1, then IP add 130.15.194.2 255.255.255.128. Enter. No shot. We're going to configure the int G00 also in G0/0 IP add. This is the local area network of this router. So the IP address that we are going to use is 130.15.195.1 255.255.255.128. Enter. No shot. Then we're going to target also the int 00. int SE000 IP add 130.15.194.129 255.255.255.128. Enter, shut. So basically, this router is good to go. We go to the next router here and configure the interfaces. So int SE000. I hope this is 0 enable MPP int SE000 IP add 130.15.194.130 255.255.255.128. Enter, no shut. So the serial interface is already configured. Let's go to the LAN, the two LANs in G0/1 IP add 130.15.196.1 255.255.255.128. Enter, no shut. Then apply in G00 aside. We're going to configure also its IP address 30.15.195.129 255.255.128. Enter, no shut. Since all of the interfaces are already been configured, so try to ping this computer to that computer, this computer to the gateway, so it's successful. So basically, what we are going to do is we are going to put EIGRP so that these computers here can also ping the other side of that computer, and this computer here can ping also the other side of the computer. If you will notice, it's failure. It's a failure because there is no protocol set that makes this router communicate. That's why at this side here, we are going to create an EIGRP command. So enable, so config T. Once you are going to give an EIGRP command, you have to start with router EIGRP. Then you put the autonomous system number. It's the time that we are going to put no auto summary to make this computation stick to CIDR. Then you have to identify the networks that we have. We have two networks present in this router. This network is not part because it is a static route. Therefore, what we will do is network 130.15.192.0 and couple it with the wildcard mask. So take note that the wildcard mask is the inverse of your subnet mask. The wildcard mask is computed this way. So the formula to create the wildcard mask is 255.255.255 minus your subnet mask, which our subnet mask is 255.255.255.128. If you deduct these numbers to this number, this will become 255 minus 255.0.255 minus 255.0, 255 minus 255 is 0, then 255 minus 128 is 127. So 127 is our wildcard mask now. So we are going to type this one, okay, 0.0.0.127. So the next network that we are going to configure is this one. We're going to send it to our network. So that would be the 194 network. So this router is good to go. We jump to the next router here, and we are going to put the three networks here. So enable, config T, then router EIGRP 10, then no auto summary. Then we are going to put the network 130.15.193.0, 0.0.0.127, because that is its wildcard mask, and enter. Then the next network is the 15, meaning 15.192 here. So if you'll notice, once we turn on the EIGRP in between router, there is a indicator that your adjacency is already up. Then particular information such as dual will be displayed on screen because dual says this is the protocol which EIGRP used. Dual means diffusing update algorithm, and we are connected with the neighbor 130.15.192.1 via Pass Ethernet 01. We are going to configure also the network side of 128. So that would be 192.128 with the same wildcard mask. This router is good to go. So we assume, we knew that this router here can communicate with this router here. Look at that. This PC here can communicate with this router because it has EIGRP already. Okay, so we're going to configure this router also. Okay, giving the command router EIGRP 10. So summary, then identify the network with this router. So we have two networks, this one and that one. So network will be 130.15.192.128 with the wildcard mask computed as 0.0.0.127. So if you will notice that this router here is already a neighbor of this router here via gigabit 01. It also for 193.128. So basically, these routers here can communicate with each other. Ping here to this one. Okay, it's successful. Then we can ping also our main router. This side here, we're going to apply also EIGRP. So exit router EIGRP. Take note that all of our router have the same autonomous system number. So no auto summary network 130.15.194.0 with a wildcard mask of 0.0.0.127. So you have your adjacency now between this router and that router. We're going to put this network here, that is 195.0, and this network here, 94.128. So this router is good to go, and we jump to the next router here, and we have to give the command again, router EIGRP with the same autonomous system number, no auto summary. Then you have to identify the network. Network will be 130.15.195.128, 0.0.0.127, and the other is 130.15.196.0, and the last is the third network here, 194.128. You can see that there is the adjacency between your router 2 and router 3. So we mean that all of these computers here within the organization can ping each other. They are successful. This computer can ping that computer there. This computer can ping this computer here, but this computer cannot ping the ISP since it is not yet configured. So we have to configure the ISP and connect it to our border router. So no, enable config in G0/0 IP add 159.11.30.129 255.255.255.252, enter no. But since we are going to apply a default static route from our border router towards the ISP, which if ever any of these computers here would like to ping an address which cannot be found inside our organization, it will go directly to the ISP. It will go directly to the internet to look for that IP address. How do you do that? Here, we are going to give a command IP route, and we are going to route any IP addresses coming from inside, meaning the 0.0.0.0 and any subnet mask. That means 0.0.0.0 also. Then we are going to identify which is the exit. Our exit is this address here. We put that is 159.11.30.129. That is our exit interface. We have an IP route already. And this computer here, all you have to do is to run an IP route also vice versa, so that these two routers can communicate. So IP route could be any IP address with any subnet mask, and it will exit on this port here. That would be 159.11.30.129. So that's invalid hop address. Why? Because I put 129 when in fact 129 is its IP address. That's why you have to be careful with that one, because this is the 130. All you have to do is to change this one 130. So if we are going to show run this one, do show run, basically all your configuration will take place. You have two EIGRP networks and one static network to the ISP. So how about this one? Do show run. So we have three EIGRP network. Okay, we have three EIGRP network, and we have to identify whether this is working or not. So you have to give the command do show IP out in order for you to determine if EIGRP is really activated. If you look at this one, so you have these EIGRPs here, okay, coming from each side of our network. Okay, well, if you can see, this EIGRP came from 130.15.192.0. So where is that? 192.0 is here. So this network now is part of this router here. That's the idea. It is connected via EIGRP, and the rest will follow. How are we going to make this PC detect that if ever these PCs here communicate with each other using their IP address, and if not, goes out to the ISP? So how are we going to do that? All you have to do is to identify first, this is do show IP route, to check whether our route is working or not. Here, we have several IP addresses or network addresses connected via EIGRP. And we have one static route. So the static route here is a candidate for default. So meaning this is a default static route. IP address with 159.11.30.129. So we are going to include this static route within EIGRP so that this main router will propagate the static route to all of the EIGRP. So how are we going to do that? You go to your router EIGRP, then we have to give the command redistribute static, so that this command enables the EIGRP to propagate the default static route to all EIGRP. So that means that this IP address now will become the gateway of last resort. So when we say the gateway of last resort, if ever no IP addresses found here and pinged by each PC in a different network, it goes directly to the gateway of the last resort. We will try to identify if that command is already propagated here. How do we know? So, do show IP route. Here you can see now different, this one, these are different EIGRPs. Let me see if do show IP route. If the static route is already propagated to each network. So we do fast forward, we will check enable show IP route. There you are. So you can see this one. Part of your IP route, there is already the DX. It means that D is what? It's an EIGRP. And the asterisk means that there is a default candidate. And that default candidate is an X. What's an X? It says here, it's an external EIGRP because it's out of the scope of EIGRP that we have created. We just included the static default route into our router here with the EIGRP configuration. So we are going to ping this one to that one, we believe it will work. There, successful. All of these computers now can ping each other and including the ISP. We are going to simulate if we are going to ping an IP address which is not existing on this network. I ping 130.15.195.10. We are going to simulate it. Let's see where will this packet go. Okay, so there is no 10. Our network found that particular PC bearing the 130.15.195.10. How about we are going to simulate this one and look for an IP address which is not existing. Like for example, google.com. Is there any google.com in our network? None. Therefore, it will go out to ISP and look for it. Let's try. Let's say the google.com IP address is ping 200.15.198.201. I think this is not existing. Where will it go? Follow the packets. Okay. There, it goes out from our ISP. Determine where is that IP address. So it will ping from time to time until it reaches its time to leave. That's it. So our network now from EIGRP is configured and our gateway of last resort goes to the ISP there. The purpose of the ISP is to determine whether IP address cannot be found here inside the organization, computed, and it goes to the ISP for checking. What is this LO all about? This LO is just a logical interface which we are going to use for checking purposes. If we are going to IP this one, we are going to IP interface LO 0, we'll put an IP address. Like for example, IP add 159.11.30.33. 255.255.255.252, enter, no shot. Basically, we have created a null interface so that we can check whether this router is working. Why? Because we don't have any PCs there. Check. So we are creating a null interface or a logical interface for the purpose of checking if that IP address is working. Okay, take note that IP address that we use is 159.11.30.133. We have to ping it, okay, for checking if our ISP is working or not. 59.11.30.133. It pings. Even if there is no PC, it replies back. If you're going to simulate it, it goes to that particular loopback interface. There, just checking. So check, okay, it goes down and determine that the ping is correct. Okay, so I guess that would be the end of our presentation, and I hope you get the gist of this topic. Thank you and practice well. Goodbye.